Alright everybody, welcome back. This is the second video for section 14 of Unit 1 of AP Calculus, connecting infinite limits and vertical asymptotes. In this video, we're mostly going to just work through some examples of finding vertical asymptotes and even removable discontinuities based off of the limit behavior of the function at our candidates for where asymptotes might occur. So, if you remember from the last video, we identified potential places of asymptotes occurring largely by looking at where the denominator of these rational functions are 0. So that's where we're going to start in looking for our candidates here. So we're going to start with setting x squared minus 4 equal to 0 and solving that for x. And those are going to be our two candidates for where there potentially could be vertical asymptotes. So once we've identified those candidates, what we're going to do is we're going to do a little limit analysis of this function. We're going to look at the limit as x goes to 2 from both sides of the function and see what happens. And we're also going to look at the limit as x goes to negative 2 from both sides and see what happens. And instead of handling this algebraically, I'm going to go ahead and use my graphing calculator and make a table of values in order to help me find the limits as x approaches 2 from the left and right and as x approaches negative 2 from the left and the right for this function. So I'm going to go ahead and enter this function into my calculator. X squared minus 2x minus 8 over the quantity x squared minus 4. And first I'm going to set up the limit around 2, since that's the first set of limits that I found here, that I wrote here on my paper. Let's go ahead and set the table up around 2, and we'll see what happens. And it looks like as I approach this from the left, the values are getting to be larger and larger positive values. So the limit as x goes to 2 from the left is positive infinity. And as I go to 2 from the right, it approaches larger and larger negative values. So that limit's negative infinity. We'll talk about the conclusions based off of these in a second after I've found all the limits that I need. And now I'm going to set up my table around negative 2 to find the other two limits. And when I look at these, it looks like as I approach from the left and from the right, this approaches 1.5 from both sides, or 3/2. Okay, so let's draw our conclusions from this. We said yesterday that there's a vertical, or not yesterday, in the last video, that there's a vertical asymptote if the limit as x approaches a from either the left or right approaches either positive or negative infinity. So once I saw these infinities cropping up here with 2, that told me that I had a vertical asymptote there. And the fact that these limits don't approach positive infinity or negative infinity, if you remember back when we were talking about types of discontinuities, this characteristic where the limit exists but the function does not at a point is indicative of a removable discontinuity. And so there's a hole in the graph here, a removable discontinuity, and the x-coordinate of the removable discontinuity is negative 2, and then the y-coordinate is the value that we found for this limit. And so if I were to look at the graph of this function, I would see a vertical asymptote at 2, and I would see a removable discontinuity at the point negative 2, 1.5, if I'm graphing it with something where I can see removable discontinuities. All right, let's go ahead and continue on to the next example. Example 5. It's known that the limit as x goes to -6 of the function g of x equals -infinity. Which of the following could be a likely table for g? If we look at these tables, since we're saying that the limit is -infinity, that means it needs to approach -infinity from both the left and the right as x gets closer and closer to -6. And if we look at these, this one gets to be bigger and bigger negative values from the left and bigger negative values from the right. So I think this is my answer right off the bat. Let me confirm by looking at the other ones. Part B, we approach -infinity from the left, +infinity from the right. So that means that the limit isn't -infinity. The limit does not exist. For part C, we approach +infinity from the left and -infinity from the right. So again, that limit does not exist because the two don't match. And then part D, g of x approaches +infinity from the left and +infinity from the right. Therefore, the limit as x approaches 6 of g of x for this table would be +infinity. And so A was our correct answer. All right, let's keep motoring. Example 6, find the vertical asymptotes and removable discontinuities of the function. Again, I'm going to set my denominator equal to 0 to find my candidates. And those candidates are 3 or -3. And then I'm going to analyze the limit behavior of this function. In order to determine whether these are asymptotes or removable discontinuities. Okay, so I'm going to go ahead and type my function in there, x squared plus 5x plus 6. X squared plus 5x plus 6 over x squared minus 9. And we set up our table around 3. And look at our table. And from the left, we're approaching -infinity, and from the right, we're approaching +infinity. So that tells us we're going to have an asymptote at x equals 3. And let's see. Set up our table around -3. And it looks like we're approaching 0.16 repeating from both sides there. And if you don't recognize 0.16 repeating, that's, 1/6. Okay, so I have a vertical asymptote. At x equals 3. And I have a removable discontinuity at the point -3, 1/6. Okay. By the way, real quick, 2 pet peeves. Pet peeve number 1, please note that this word asymptote, the second to last letter is a T, not a P. As a longtime calculus teacher, I've heard these referred to as asymptotes, way more than I would like. Kind of feels like nails on a chalkboard to me. I think a lot of that has to do with students studying isotopes in chemistry. But that is an asymptote, not an asymptote. Please make sure your pronunciation is on point there. And the second thing is when we write vertical asymptotes are lines, and hence we need to write them as equations. X equals 3 or x equals 5. I've seen students over the years who have written them as, the vertical asymptote is 3. Well, no, it's not, because 3 is just a number. 3 doesn't make a line. Vertical asymptotes are lines, and so we need an equation of a line to represent that vertical asymptote. So 2 pet peeves that you want to avoid. All right, let's go ahead and look at the last one here. Find all of the vertical asymptotes and removable discontinuities of this function, y equals blah, blah, blah. So again, I'm going to go ahead and set up my denominator equal to 0 to find my candidates. I'm going to solve this by factoring. So 3 and -2 are my 2 potential locations. And then I'm going to do my limit analysis of this function. I need to look at the limit as x goes to 3 from the left, the limit as x goes to 3 from the right, and the limit as x goes to -2 from the left, the limit as x goes to -2 from the right. And so I set this up in my calculator. I'm going to go ahead and put that function in, 2x squared minus 9x minus 5. 2x squared minus 9x minus 5 over x squared minus x minus 6. And I'll set up my table. First around 3. And we see from the left it approaches positive infinity, and from the right negative infinity. So we're going to have an asymptote at x equals 3. And then I set up my table around -2. And from the left that approaches positive infinity, and from the right negative infinity. And so I'm going to have an asymptote there as well. And so my vertical asymptotes are at x equals 3 and x equals -2. And there are no removable discontinuities in this function. All right, that's it for this video. Video number 2 and the end of section 14 of Unit 1. We'll be back with you next time to talk about section 15 of Unit 1 in AP Calculus. Hope you can join us then. See you everybody, and have a great rest of your day.